so much. I know there are many things going on with everyone's life, and I'm very grateful that you spend the next 75 to 90 minutes with us. We're very delighted to have Dr. Cory Kidd here. So let me start off by asking a couple questions. How many of you would love to have a robot to help you wash dishes and fold clothes? Okay, and she even has a name for it. And let me ask you some of the younger adults here. How many of you would like to have a robotic friend? Oh, younger adult. All right, so the whole concept about robotics is really not new. In fact, you know, Blade Runner, iRobot, there's so many movies out there that talks about robotics. But the whole concept of social robots, where you're actually interacting with the robot, that the robot needs to understand your facial expression, understand your emotion, that becomes a different level of complexity. And without a doubt, robotic is becoming incredibly attractive to especially the Silicon Valley companies, like the one up the street here, Google. If you take a look of Google's merger and acquisition Wikipedia, I believe the last 9 months, most of the investment they've done, it's been around artificial intelligence and robotics. And if you take a look at the Economist magazine for this, this month, there's actually a 14-page article specifically around the rise of robots. So I think it's a very important topic that we would like to cover for our MIT community. So we are very, very grateful here today to have Dr. Cory Kidd, who is an MIT alum from the Media Lab. He graduated in 2007, and before he graduated, there were, what is it, New York Times and Gray America, was it? Good Morning America. Good Morning America already got interested in the things that he's been working on. But he decided from the cost and design perspective, he launched his business actually in Hong Kong. Dr. Kidd is considered a leader in the artificial intelligence and social robot space, so we are very grateful to have him here today. And we also are lucky to have Autom with us. So without further ado, Dr. Kidd.
All right, thank you for the introduction. All right, welcome everyone. Can you hear me? Yeah. All right, great. So I'm going to jump right into this. This is going to be something that we all participate in tonight. All right, so you're welcome to shout out questions. Raise your hand so I can see you. We are recording this, so I'll repeat your question so that everyone can hear it. And I've got a couple other things set up here. So feel free to jump on Twitter. I'm on Twitter, Cory K. Autom is at Autom. We've got a hashtag for MIT Robots. And I'm trying out something else tonight. This is a small startup that I'm helping to mentor. Meet.ps/robots. If you go there, you can type your question in. If you don't want to shout them out, I'll be watching for them up here. And you can vote on a few things through that as well if you want to try that. So that'll be at the bottom of the page here if you forget what it is. And there's MSFT open if you want to get online. All right, so let me jump in here. I am going to give this talk in a few parts, okay? So the first is I'm going to give a short history of robotics. That'll be just a few minutes, and this is going to be a combination of things. So a history of robotics would not be complete without sci-fi, so we'll start there, and we'll interleave that with actual real robots that are sold and used for a number of uses. So after that, I'm going to talk for a minute about the research that I did while I was at MIT. So as you heard, I finished at MIT in 2007. I started there in 2001, so it was about 6.5 years of research over a variety of different robots and a number of different applications, and a little bit about how I've commercialized the work that I've done there. So I know a number of you have come up and said hello to Autom, the weight loss coach that's sitting up here. So that was the culmination of my PhD work has led into the company that I've developed ever since then. Oops, slide behind up there. And finally, I want to talk just for a few minutes about the future of interactive robots, kind of where we're going from here, where the market started in terms of going from research to actual products that many of us have at home and many more of us will in the future, and thinking about where we might be in 3, 5, 10 years from now. So again, very interactive. Feel free to raise your hand with questions at any time. But I'm going to start in with a little bit of history of robots. So can anyone tell me where the word robot comes from? Right in the front row.
Worker or slave?
Exactly. So it's a Czechoslovakian word, and it comes out of a play, RUR, Rossum's Universal Robots, right? So these were the robots that were drawn there, and they were meant to be workers, right? Slaves. So this is where we get the word from. Now, the meaning has changed a lot over the last, let's see, it's been about 85, 87 years, I think, since this play was written. It's a much more broad meaning now in terms of robot. But if we think about the etymology here and the history of it, this is really not a very old word in our language. It's something that's very new. And so we've put a lot of meaning into this word, particularly over the last few decades. So to me, that's pretty interesting, right? It's a relatively new thing in our language that we use in a lot of ways now. So this was the start of the word robot. As I said, I'm going to interleave this with some commercial robotics. This is the Unimate. So most of you have probably never seen one of these in person, but this is one of the top-selling robots of all time.
And it was made, designed at MIT by me in the 1970s.
Here, one more time. We didn't get that on audio there.
I'm Victor Scheinman, and it was designed by me in 1973 for Marvin Minsky at the AI Lab. And I started the first robotics company in Silicon Valley around that time to make them for him and then commercialize them.
Thank you. So only in an MIT crowd do we get an experience like this. I'm not sure how many times I've used this in a talk, but I can assure you that that's never happened. So come up afterwards. Let's get a picture together here. So you brought up something, or someone there, that's been important over much of the history of robotics. While I was at MIT in the last decade, I took artificial intelligence from Marvin Minsky, who is still actively teaching his course. And I'm sure it's evolved a little bit since then. Now he professes to hate robots. But so obviously a big history at MIT, right? Many of us in this room know about it or have been involved in it in many ways. So this robot is really the start of commercial robotics, as you heard, around industrial automation. So what year was this commercialized?
About 78.
78. So almost 40 years ago is kind of our history of commercial robots here. So in terms of technology, relatively short time span, and we've done a lot in that time. Question up here.
What did this robot actually do?
So the question is, what did this robot actually do? And I'm probably not the best one in the room to answer that.
Well, it came in several sizes. This is the smallest size. There was larger size, quite a bit larger. This weighed 15 pounds. The bigger one weighed about 100 pounds. And then there was an even larger one that weighed 1,000 pounds, which was much bigger. It was used for all sorts of applications, everything from knee replacements and surgical procedures to semiconductor, wafer handling and processing, to the larger ones, spray painting, welding on assembly lines, robot assembly lines. The word Puma came from General Motors, who bought the first, a little larger one of these things for their lines. Programmable universal manipulator for assembly was the robot. It was their concept of robots working at jobs that people do. And in fact, it was designed to fit into a same work cell as a person would fit into. And so you could have a robot sitting right next to you working on the assembly line. And if it broke down, you could put a person in there to replace them in the early days. And many, many applications in semiconductor, in medical fields.
So can I ask you a follow-up question to set up for something we're going to talk about?
Yeah, right.
How'd you program it?
How did I program it?
How was one program when it was to be put in place?
This one, that we call, that little red box there, that's just called, that was what we call the interactive command module, the ICM. But That was not how we programmed it. It was all programmed from that monitor in the background. And it was programmed using a language called VAL, Vic's ARM language, in my case, Vic ARM language. The company was called Vic ARM, and it was right here in Mountain View on, on Dana Street, not far from here, originally. And I sold it to Unimation, the technology to Unimation, because I didn't have the ability to make them in the quantities for General Motors at the time. And so I worked a deal with Unimation to make them. But it was programmed in a high-level programming language at the time.
Thank you. All right, better history lesson than I could have given on that slide.
Right. It's not where you let it through. You could lead it through a task manually, but that's the very basic way of doing it, and it's really the most difficult way to do it. We dealt all with. It had a real-time operating system and programming environment where you worked in a Cartesian space, and you told the robot what coordinates to go to. It uses the concepts of transforms and trajectory, real-time trajectory control. So it could move in straight lines, like a person can move his arm in a straight line.
Thank you. All right, so let's talk for a second about a very different vision of robots. You probably know this one, right? So for many years, Hollywood did all of us in the robotics industry a big disservice. All the robots ended up being very scary and were out to attack us. And I think probably the vision of robots in a lot of cinema through the late 70s through the early 90s was something like this. And this was, there weren't tremendous advances in commercial robots that you or I might know until the mid to late 90s, until this guy. How many know this one? AIBO. A few of us. Yeah, most of us know the AIBO. So this was a new low-cost, if you will, consumer robot. They launched it around $2,500 US. I think by the end of AIBO's career on the market, they had them down to maybe $1,700 or $1,800 US. And part of that's just the history of this product. So when they started building it, it was never intended as a commercial product, but Sony thought it was cool enough that they tried selling it, and they did. I remember having probably this version of it at some point in the 90s where I did some programming and some interactive work with this. So, going from the design of this to the design of this, right? We're talking about a very different form factor, a very different use of robots. They're going from something that we might find in a factory or a workspace to something that was intended to be something we play with at home. So the advances that were starting to happen in robotics were obviously around the design, quite a bit around the interaction. We were starting to think of this technology in a very different way. And at the same time, I think these, again, are intertwined. Hollywood's vision, the science fiction vision of what a robot might be, starts to become more friendly and more approachable. So I'm sure some of us remember this movie as well, right? So we've got another robot that starts to look more human-like, but not human-like in this scary sense, right? But in the friendly, approachable, helpful way. Right, so Hollywood is starting to help us out, right? Those of us trying to make this technology a reality, we start to get friendlier images of what it might look like. And if you look at many people who are interested in robotics, many of us in the field or in technology in general are definitely influenced by things like this. My advisor at MIT is Dr. Cynthia Brazil. She's still at the Media Lab. And whenever she talks about her personal history of robots, the story always starts with the movie Star Wars. Her story is that that's what convinced her that she wanted to build robots, right? So there are a lot of people for whom the vision that Hollywood or science fiction authors put out there really helped to shape the kind of thing that they build. So one of the biggest advances in terms of consumer robotics is this guy right here, the Roomba. So this is a relatively simple robot, and we'll come back to this towards the end when we start talking about where this field is going overall. But there's 8, 9 million of these out there. I mean, how many people in this room have one of these at home? Not a huge number, but quite a few of us, right? And I can ask that in pretty much any room. I can tell you that that is not unique to just an MIT crowd.
How many use it every day?
Good question.
How many? Anybody use it?
Yes, the question was how many people actually use their Roomba every day? You got one here. Okay, so pretty small number. Maybe 2 back there. So, and the question here is a good one, right? We're making advances in the technology. We're creating things that can be sold at the price point of a consumer product. But that doesn't mean that we're there yet in terms of developing this technology. I would actually argue that we still have quite a long ways to go. But at the same time, right, Hollywood is making robots friendlier and friendlier, right? This is obviously a very friendly, cute robot. So animated, of course. But this one has projected the idea of a robot into a lot of people's minds. Now, while I have that on the screen and this robot Autom sitting here, how many of you would say these 2 robots look alike? More than I thought. Okay. Why? Eyes. What else? Head. All right, so head, eyes, and body make these look alike. So that must mean because this has head, eyes, and body that these 2 look alike, right? No. Why not?
Because
Different shape? What else?
cartoon rendering.
Friendly, exactly. So, there's a lot of design language that's being developed around robots as well. And we've done a lot of work in Autom in terms of the design language and how she looks and trying to make her look friendly. But the reality is most of that work on a design language around robots is still happening in places like this, in Hollywood movies. So that's starting to change now. And I think this is a very exciting time to be talking about interactive robots because the world is very much changing in terms of the ability to overcome the challenges that we just heard about. You sold your company because you couldn't produce enough. As of a few years ago, that was still a big challenge for anyone trying to build a robot. A lot of things around manufacturing, the prices, the costs around manufacturing are starting to change, and partly because of robots helping us to build robots, means that this is a time when we're going to start to see the pace of development and innovation around this change more rapidly. So 2 last robots, just to show some of the breadth of what's happening here. I know a number of you know this. It came up in conversations while you were talking about Autom in the last hour or so. This is the Da Vinci surgical robot. So this one is definitely at the other end of the price spectrum from Autom. We're talking about millions of dollars instead of a couple $100. But this is obviously a very complex, high-tech robot. So this one is used, of course, in an operating room to perform surgical procedures. So what this is helping to show us, we heard that robots, some of the early robots that we saw were used in some medical procedures. This is becoming much more standard, commonplace, and robots are going to many other places, right? From vacuuming our floors to the operating theater in a hospital to space. So this is a robot that I fortunately had the chance to work a little bit on, let's see, about 10 years ago now. So this is the Robonaut Astronaut, designed to help astronauts on the International Space Station. So the premise behind this is that doing spacewalks is very dangerous for astronauts, having to actually go out in space and leave the space station, or in previous decades, leave the space shuttle or whatever we have in the future. And so instead of having to send 2 astronauts out to do some jobs, send an astronaut and a robotic astronaut out to do it. So there were a lot of interesting advances made in terms of the development of Robonaut. So as you can see, this is a robot that has a similar form factor to a human. Like we heard about a minute ago with one of the early manufacturing robots, you could put it in the same place as a human. This one was also designed to use the same tools as the astronaut. So you can see they're shaking hands with the robot shaking hands with an astronaut. So that robot has the ability to use the same set of tools that would already be on the space station. Question in front?
Does does that robot not only have physical skills but also psychological skills, like how, like learning without like digging into the robot and then programming, but like teaching it like how you would teach a normal human?
They're definitely working on that. So that's a great question, right? How does this robot learn what to do? So when you're up, besides programming, right? So there's, of course, a lot of programming that goes into it. But one of the areas of work that's been done in research in general over the last few decades, but also specifically on this robot, is what's called learning by demonstration, right? So, hey. All right, so for those of you who couldn't see, and it's kind of hard up front, I just handed him this remote. And then after he took it, I took my hand and did what I wanted him to do, and he figured it out immediately, right? I didn't say anything. So it's very easy for us interacting with someone who has the same body shape as us to express something that we want someone to do. So that's a bit of what's happened on Robonaut. Question in the back. Shout it out.
I thought they always said not to do something like that, or else robots might take over the world.
All right, so the question is, why are we building things like this? Because the robots are just going to come back and get us all. And I think that's one of those areas where Terminator and the rest of science fiction is giving us the wrong message. Once you start building these, how many robots have you built? None? All right, well, we got to work on that. We'll convince you by the end of the night you have to start building robots.
The ones that they build are kind of expensive.
Yep. So many of them are, but the good thing is they're becoming less expensive every year. So once you start building them, you realize how much work goes into it. So I think we have a long ways before they're going to become smarter than us. Question in front.
So,
go ahead.
if you had more of those and you didn't program them yet, would you program the original one to program the rest of them, or would you have to program them?
Good question. So the good thing about programming a robot is once you've done, it's in software, so you can transfer it to all of them, right? And they can all do the same thing. I'll give you an example with Autom here in a few minutes. All right. So I'm going to move forward a little bit and talk about this area of social robots. Okay, so this is, in terms of this name, social or sociable robots, relatively new. It's come about in the last 20 years or so. One of the robots that's recognized as one of the first social robots is this robot here called Kismet. Any of you seen that one before? Few of us, right? So this is MIT robot from the late 1990s. I mentioned a few minutes ago that my PhD advisor in the media lab, come back to you one second. My PhD advisor in the media lab was Dr. Cynthia Brazil. This was part of her PhD work in the computer science AI lab, or the AI lab at that point in time. So Kismet was one of the first robots that defined what a social robot was, and that was about understanding something about human interaction. So in the case of Kismet, it did what they called babbling. Okay, so kind of like maybe a young child might before, as they're trying to acquire language. There's some intonation to it. There's, maybe some prosody, and you can pick out some emotion, but there's definitely no words there. So that was the way that Kismet expressed to people. Kismet had a lot of processing power behind him. So the robot itself, the head is, only about this big. If you want to see this one, next time you're back at MIT, go to the MIT Museum. It's part of the permanent collection there. You can see it. What you don't see there in that little box on a table about this big is the rack of computers that had to go behind to actually run Kismet and do all the processing. So Kismet had a vision system, a speech recognition system, so it could also pick out the prosody in the human voice. So there's quite a bit that went into the models for how Kismet reacted. And one of the main goals of this work was to make it feel emotionally connected to you. And if you have a chance, you can also go online and find some of the videos of Kismet to see how strongly people reacted. All right, let me take a question right in here before I continue. Go ahead.
Can it speak?
Can Kismet speak? Kismet talks kind of like, Right, so he doesn't use words, but he tries to express emotion through the sounds that he makes. Any other questions before we go on? All right, so let me jump sort of ahead and sort of backwards, okay? So ahead in time and ahead in research, backwards in terms of design of a robot. So I went back to grad school in 2001, so about 13 years ago. And I had been working before that at the intersection of healthcare and technology. This is what I've done for about 16 or 17 years now. And when I went back to school, I thought that I wanted to stay in this broad space of finding cool, new, fun technologies, but finding great real-world helpful applications around healthcare for these technologies to be useful for people. And Cynthia had just finished at the AI lab a year or two before, accepted a faculty position at the media lab, and I interviewed with her and thought that this technology sounded pretty cool. I don't really know where it's going to go yet, but let's go explore it for at least a couple of years and see where it goes. So I started off, and my master's degree work for about 2 years was running a series of experiments, used about a half dozen different robots, maybe 400, 500 research subjects. And obviously there was technology involved. I was using from a very simple robot here, which was just a pair of eyes that could look around and wink and blink, up to much more complex 70 degree of freedom robots. I'll show you some other pictures in a minute. So a whole range of robots. So there's technology in building, programming these robots and creating the experiments. But these studies were all about psychology. So it was looking at the psychology of interaction, and in particular, comparing to something that we've known quite a bit about for the last half century or so, the field of human-computer interaction. So HCI specialists have looked at all different aspects of how we interact with computers, and of course, the field of psychology looking at how we as people interact with one another. And so that was kind of the foundation of the work that I was doing. And as I said, in particular, I was comparing interacting with a physical robot versus a virtual character on a screen. And I'm not going to show all of the robots here, but in general, we did a bunch of different studies. Some of them, in terms of the animated character, were much more faithful to the real character. We tried to control for as many variables as possible to make very well-controlled experiments. And over the course of these studies, we found two major differences that held when you compare people interacting with a physical robot that's there in front of them versus a virtual robot on the screen. Okay, so this is one example here, a very simple one. Some of the robots, of course, are much more complex. But overall, what we found is when we're interacting with a physical robot, it's more engaging than interacting with a robot on the screen. I'm more drawn into the interaction. And of course, a part of that is novelty. It's like, oh, wow, I get to talk to a robot, right? How many of you came up here because there was a robot sitting here before the talk? Of course you want to try it out and talk to it. But the interesting part psychologically is after that initial novelty wears off, the engagement continues to last much longer with the physical robot versus the character on the screen. So I'll come back to that in 1 second. But the other difference that we saw was we were trying to convey information to people. So we used textbook information. Math, science, geography, the kind of things that you learn in school. We used health-related information. Didn't really matter what the information was, but when it was coming from the physical robot, people who were interacting with it saw that information as being more credible and more informative. They found the robot itself to be more trustworthy, more believable. They developed a better relationship with that physical robot versus something that looked identical on a screen. All right, so those are the two big differences, right? Engagement and length of engagement and the ability to convey information. Now, as it turns out, this parallels exactly what psychologists have found about face-to-face versus mediated interaction. How many of you got stuck in traffic tonight? Yeah, most of us. Wouldn't it have been easier to pull up a video of this on your screen instead of, all of us coming out to be in the same room? Right? I've spent, I was talking to Ivy beforehand, I've spent about 150,000 miles a year flying on planes the last 5 or 6 years because I go meet face-to-face with customers. I mean, many of us are in business, understand that we do this implicitly. We show up face-to-face and meet with people. As it turns out, there is a good psychological reason for that. When we're talking to someone face-to-face, we trust them more. We develop a better relationship with them. We're more likely to believe what they tell us. Everything I just told you about robot versus a character on a screen, we've already known about face-to-face versus mediated communication. And it doesn't really matter if that's IM or email or phone or even a great video conferencing system. Of course, there's some difference among those, but none of them come even close to the face-to-face interaction. And what I found is those differences in talking to someone face-to-face versus talking to them through some sort of mediated channel carry over very strongly into technology. And having that robot in front of you is more like that face-to-face interaction. So that was the foundation for a lot of the work that I've ended up doing over the last decade or so. So we'll come back to that in a few minutes when we talk about Autom. But I want to tell you about one other study first. So this is Mel. Mel is a robotic penguin built by a former Disney engineer. So the interesting thing about Mel is not so much his makeup, right? The physical robot there is maybe a little lacking in some ways in terms of at least today's technology. Mel's a little more than a decade old. But the software behind Mel was very interesting. So Mel, 10 years ago, was built at and lived at MERL, Mitsubishi Electric Research Lab. And the researchers that I was working with, Chuck Rich and Candy Seidner, had been working for many years on a system called Collagen, a language understanding and conversation generation system. So Collagen could have fairly complex conversations with someone about a certain topic. And this being Mitsubishi Electric, the applications of those were very fancy things like, we don't have one right here, but you imagine your air conditioner control on the wall, right? As it become more complex, it become harder to program. So that was one of the applications. Or this, again, 10 years ago was the very early days of some on-screen display on your television. That was another application that they were working on. So it was limited to, for the most part, these little screens, maybe your TV screen. Of course, the size of those were starting to grow 10 years ago. But they were interested to understand what would happen if they put this on a robot instead of just on a screen. So between finishing my master's and starting my PhD at the Media Lab, I went and spent a summer down a couple blocks away from the MIT campus in Cambridge at the Mitsubishi Electric Research Lab. And I helped them design and run some studies of people interacting with Mel and using this language understanding system. So this is another, what I found to be very interesting result here. So let me describe first Mel in the study. All right, so Mel, as you can see, is a pretty simple penguin. He's got a couple of arms here. They can flap. His head can move. His beak can move. That's it. All right? Those are sewn-on doll eyes, a little pair of fake doll glasses on there. You can see in the background, some of you may remember these, one of the original webcams from, I don't know, probably close to 15 years ago now. All right, so that was Mel's eye, and there were a couple of computers off to the side. One of them was running the conversation system. The other one was running the vision system. And so as I said, the software was pretty good in terms of what it could do. And what Mel was doing was giving a demonstration of another project there at MERL. So it happened to be a set of glasses that could know when it was empty or full. And those were sitting on the table next to Mel. Okay, and while Mel was talking to someone, the speech was coming out of you can see the computer speakers kind of on the side, so some big bulky ones. There's some microphones there so we can pick up what someone is saying. And while he's talking, the beak moves in time to the speech, right? Really simple in terms of the technology. And that camera in the background was picking up where someone was, so if you moved around, Mel would orient his head towards you. All right, that was it. I brought 40 people in to talk to Mel. And for each of them, he was giving about a 5-minute demonstration of this other project, okay? And you kind of say, here's what it's about, and it was interactive, right? So we made whoever was in there, pour some water into the glass, pour it back so they could see it really working. Isn't that great? And at the end of that, 4 or 5 minutes, for each of those 40 people, as soon as Mel's demonstration to them was over, I took them right outside the room, and I sat down and I gave them questionnaires about their experience. Okay, so one other thing before I explain the questionnaires, or really just one question on those questionnaires. This was a controlled study, okay? So half of the people were assigned to one condition where Mel acted as I just explained. For the other half of the people, 20 people, I made one small change. And that was I unplugged Mel before they started, okay? So the speech and all the stuff running on the computer still worked the same way. So we could still give the demonstration. The computer was still running the conversation system. But throughout the entire thing, Mel sat there just like this. Never moved his beak, his head, or his arms. Okay? And so when he did move, he did things like didactic gestures, which means, when I'm talking about this thing over here, right, I look, I talk about Autom, I look over at her, or I gesture to her. So Mel would do that, right? Look at the glasses over there and turn his head. Or, when the person would move, he would move over there, or, use his little arms when he was talking about something the first few times. And so for the other half of the people, he didn't do any of that, okay? So now I said, people spent about 4 or 5 minutes, and I took them outside of the room. And the first question on the questionnaire that everyone was asked was, while Mel was talking to you, did he look around and move move his beak? All 40 people said yes. All right, and these are people like you and me, right? So relatively well-educated. They were not stumped by this technology or the really difficult question. But it was that, okay, you've got something that seems pretty smart, right? It's having a conversation with me. It's telling me about this thing in this research lab. It must have moved around while it was talking to me. Okay, so this tells us something, right? That when we think something should be doing something, we kind of fill in with our minds what might be happening here. So yeah, that robot must have moved. Okay, so the rest of the questions that I asked people, and this was for them probably a very tedious psychological experiment, right? I asked them a bunch of questions about how much they enjoyed this. How interesting was Mel? Would they recommend one of their friends come see it? Would they come back and talk to Mel about another demonstration? Was Mel relatively intelligent for what he was, right? So a bunch of different things about their perceptions of their experience. And on every one of those scales, there was a clear difference between the group for whom Mel moved and the group where Mel was just sitting still, okay? So this tells us a lot about ourselves psychologically, right? Something seemed kind of off, but we couldn't quite place it, right? We've probably all had that experience where we're talking to someone and something just seems a little off about them, right? Anybody here been to MIT? Might know one or two of those people, right? But we don't necessarily know what it is, right? Something just seems kind of wrong, and it affects our perception of that experience or that person or whatever it might be. And so what we found is this is actually really important when we think about designing a robot like this or any other social robot. We need to really pay attention to what the social cues and the social signals that this technology is both sending and receiving, right? We can leave it out or we can do it wrong. And people might not be able to say, we as the designers might not be able to say, oh, that's wrong, it's this, right? We're going to kind of fill in because we have expectations about how it should or shouldn't be working. But it will really impact our experience of it. It will really change the way that we think about this technology. It will change the way that we use it or don't use it, right? We had a great question earlier about how many people use their Roombas. Part of it's about the utility of it. Part of it might be about this experience, right? The Roomba obviously doesn't have a face, but we personify it. I don't know how many of you know, but there are websites where you can go buy clothes for your Roomba. Right, so we think about them in very human ways, even if it's a relatively simple technology. But the way that it interacts with us socially is actually very important. I've got a question on the far side. Shout it out. Yeah, so he was saying, for those of you who couldn't hear, that the Roomba broke down, so that affects how we think about it. That's definitely important, right? We want our technology to last, to be robust, and if it breaks and is not easy to use, or if it takes a lot of maintenance, that's definitely more difficult. Any other questions right now? All right, again, feel free to raise your hand anytime. So, some of you have probably seen this robot. A few of us, yeah, so this is Leonardo. This robot is about 70 degrees of freedom, about 70 motors here, and roughly half of those, around 35, are in the face. So this was a collaboration between our research group at the Media Lab and Stan Winston's studio. So Stan Winston is a Hollywood studio that has built a number of other robots that you know, like the dinosaurs in Jurassic Park, and a bunch of other things that have been in movies, right? So they're really good at making things that look good. And if you look closely here, if you get up really close to Leonardo, still very convincing in terms of realism. Every hair on there was a hand-sewn yak hair. So I don't remember how much this robot cost, but it was by no means inexpensive. And it took us, I think, about a year through design, construction, and initial programming just to get Leonardo moving. So I mentioned earlier, I'm not going to go into any of the studies here, although we actually had a question here that related to it about how do we teach a robot what to do. Some of the work that ended up being done on Robonaut was initially done here on Leonardo. That's one of the things that our group had the opportunity to contribute to what NASA was doing. And so, I showed you the example a couple of slides ago of the eyes. I told you I worked on a whole range of robots. So this kind of shows you from simplest to most complex in terms of these studies that I was talking about. So a bunch of different types of robots. So that set the tone for a lot of the background work that I had done at MIT and understanding a lot about the psychology of the interaction, right? So again, obviously a bit of technology involved in terms of the building and programming robots, both in terms of simple motion to the artificial intelligence to get them to carry out interactions or generate conversations. But going on from there, I was looking, went back to looking at the healthcare applications of this. Right, so to recap the two things that I found in the early set of studies, it's about being able to engage someone over a long period of time and about being able to effectively convey information to them. And so the broad application area that I started looking at for those advantages of using a robot is around behavior change. Right? Behavior change is about convincing me to do something, but more importantly and more challenging is helping me to stick with it over time. So that's really where the research I did for my Ph.D. turned to. So question in the middle here.
Is the hair that he has new?
The hair that he has came from an animal that got shaved to clothe Leonardo. So it's real hair, but not from a person. From a yak. Other questions? Yes?
How long did it take to program him?
So the question was, how long did it take to program him? And that depends on for what. So Leonardo is designed as a research robot, a research platform. So he was used for many years in terms of doing a lot of different research. For doing any one thing, to first get him moving probably took several months while he was being built to get the first motion happening. And then he kind of got smarter and smarter and got more and more capabilities. So there were quite a few graduate and undergraduate students who spent years programming part of the capabilities that went into Leonardo. And some of that happened before Leonardo even existed. So it's using software that had been used on a number of characters and robots before that. But there's many, many person years goes into Leonardo. In the middle.
Can Leonardo speak?
Leonardo sometimes could speak. So since he was a research robot, we used him for different things at different times. But in some of the things that we used him for, Leonardo would speak. Yes?
Can he handshake?
Not very well. So kind of like a cartoon, Leonardo only has 4 fingers, right, instead of the 5 that we have. And his face was very expressive. He had as many motors in his face to make him do things like we can. His hand, he could do like this. So if we were really good, we could make him grab a ball, but that was about it. So he wasn't really good at handshakes. Any other questions? Yes?
How big was he?
So Leonardo is about this tall, so maybe 3 feet, about 1 meter tall. And if I wasn't clear at the beginning, the adults are also allowed to ask questions. It's okay. You're being shown up by everyone under the age of 15 in the room, so show me that you can ask also. I think we had 1 here. All right. So as I said, I turned my attention towards the behavior change applications here in looking at what it would take to build a robot that could start to successfully engage people over a long period of time. So this work was starting around 2004 or so. I ended up working across town at Boston University Medical Center, So Boston Medical, as it turns out, has one of the leading clinical weight loss programs in the United States. And the woman who runs this, Dr. Caroline Apovian, is a worldwide expert. She's an endocrinologist with a specialty in weight loss. I met her somewhere around 2004. Picture this crazy idea that I was going to replace her and other doctors with robots. And she thought it was pretty cool. Invited me down to her clinic. So I spent my last 3 years at MIT also in the clinic at Boston Medical. That started off seeing patients actually in the clinic, just like a medical resident would. So I spent probably one summer pretty much full-time seeing patients at Boston Medical just to understand more about the clinical side and of medical weight loss. And just to give you a sense of what they do there, it's everything from someone seeing a dietitian or a nutritionist through pharmacotherapy up through recommendation to bariatric surgery. So sort of the whole range of weight loss procedures and practices. Question? No? Change your mind? Okay, back here.
In your experience, are there generational differences, cultural differences, gender differences in how people interact with robots?
Great, good question. So the question was, are there generational age differences or gender differences in how people interact with robots? So I have actually not done very much work with children. The age range in the studies that I did while I was at MIT ranged from 18 to 104. And in that range, I did not see much in terms of age differences, in terms of how people responded. In terms of gender, there are some differences, but not necessarily the ones you might think. So in terms of actual psychological perceptions, we did not see gender differences pretty much across the board. There were differences in how people responded to or were willing to talk about the robot. And if I don't come back to that at the end of the Autom story, please remind me. Yes, back here.
Sort of an off-task question. How could I access or rewatch this?
Sorry, can you say that again?
How could I access or rewatch it? You said you were recording it. Would it be accessible from, say, a laptop or something?
Recording which? The studies?
The talk,
Oh, the talk today. Let's. Yeah, the answer back there.
It's going to be accessible on the media MIT Club of Northern California website. There is a media archive link.
Okay.
Yeah.
There you go. Okay, we had another question right here.
Yep, so actually one main reason why people go to doctors is to get personal comfort and advice. Like if I have a cold, I go to a doctor and say, oh, what medicine should I take or something like that. And I'm not looking exactly for standardized response. I'm looking for more personal answers. So
Yep.
what is that?
So the question is about, we go to doctors for a lot of different reasons. And the reality of what we're doing with this kind of technology and what I want to talk about here is not about replacing doctors. It's about augmenting them. All right, so to go back to what I was doing at Boston Medical, if someone wanted to come into the clinic and see a doctor, a dietitian, or a nutritionist, from the time they called to the first appointment, the average time was about 2 or 3 months because they were so busy. All right. Once a patient got into the clinic, on average, they would come back every month or two. And that was just the most time that they could schedule. Now, if you're trying to make a change, I'll come to you in 1 minute, okay? If you're trying to make a change, being able to talk to someone every day is ideal. All right, so just in terms of a lot of the challenges that we see in our healthcare system, the number of caregivers is not nearly what we need to be ideal. So if we can augment that with technology and help the doctors to do their job better, I think is where we can really use this technology. All right, back in the third row here, did we have a question?
Can Leonardo eat something?
Leonardo does not eat. And did we have a question up front? Nope, okay. Over here.
Can I just drill down a little bit more on that age specificity? It
Sure.
seems to me that one market that I never see addressed in this, but it's very obvious that anybody who spends time in a geriatric facility is Alzheimer's patients or older patients who have less mental capability. And it seems like they would be very attracted to something like that, particularly something they could hold. And yet, does that counter from what you're saying, or are you not working with patients that were looking for an interactive emotional experience as opposed to an academic training doctor experience?
No, did look at a lot of those things. Actually, I did a series of studies. Some of you may know Sherry Turkle, who is a professor at MIT as well. Sherry and I did a series of studies together in nursing homes in the greater Boston area. And part of that work was both looking at mentally high functioning and mentally low functioning patients. And there are actually a lot of challenges around the low functioning patients in terms of introducing this kind of technology. So, for example, something like this would never work because it's simply not durable, right? They get tired of something and throw it off the table. All right, so if we're talking about, particularly advanced Alzheimer's or schizophrenic patients were two of the populations that we were working with, it was just a real challenge in introducing this. The other challenge in doing that kind of work right now is good design has not been done around the products that you might use in that setting. So I don't think I have a picture of it in the slide deck, but some of you may know the Pero robot, a robotic seal that's been designed for those environments. Okay, so this is a sort of an emotional companion is the idea behind the Pero that you could give to someone, they can pet, it will squeal back to them. Relatively simple. The company has done a bit of work around this robot and trying to show that it helps those populations. We saw a very immediate problem with this, okay? What is a seal's natural home? Water. Exactly. You give one of these patients this thing and not supervise them, they want to take care of it and put it in the bath. Not very good for a robot. So I think it is a very interesting opportunity, and I think there's been very little done in that space yet. And I've done a little bit there. A lot of the work I'm doing with my company now is really focusing on what we commonly call aging in place now, which is really where I got my start in healthcare technology. 15 years ago, I was building a research facility just to look at a lot of different aging in place technologies. And that's absolutely where we're going. So maybe we can talk about that a little more after this as well. Okay, so was in seeing patients with the doctors. I've talked a little bit about their challenges, right? They don't have enough time to help everyone. And from my perspective, if I'm a patient, one thing we know about behavior change and people is we're really great at making changes, and we're absolutely terrible at sticking with them. I mean, how many of you made New Year's resolutions this year, back in January? And how many of you did and don't want to admit it right now? Because I know more of you did than that, right? And how many of you are still sticking with them? One or two hands here. All right, so we're way too late in the year to be sticking with our New Year's resolutions. The typical change in behavior that we as a person like to make lasts us about 3 or 4 weeks. And it's not that we forget or we change our mind or we don't want to do it. It's just, life gets in the way. I get busy with work. I go on vacation. Whatever I was going to do just kind of falls by the wayside. And once it does for a few days or even a week or two, it gets much harder to go back and do it. And weight loss is a great example of this. Right, so the average diet lasts 3.5 weeks with very little standard deviation. And there's plenty of research to back that up. The average patient that we had coming into the clinic at Boston Medical had tried and failed at 5 diets in the past 2 years before coming to the clinic. Now, that didn't change their motivation going in there, right? I come in and I got to spend, I wasn't as busy as the doctor. I could go and talk to these patients for a little bit longer. And, for almost all of them, their motivation was, this time I'm going to succeed, right? This time I'm going to do it, right? And when we make a change, of course, we believe that we're going to. If not, we wouldn't make that change in the first place, right? So we're really motivated and engaged. And that's where a technology like this can really come in, right? Take advantage of that initial motivation. Be there with us on an ongoing basis in our home. Most of the people that we've given Autom to have put them in their kitchen. So sitting right there on the countertop to talk to every day. It's a great motivator that's sitting right there in front of you. And we've done the comparison. Of course, we could deliver that technology through these devices. We've all got these in our pockets or our tablets on our bedside or wherever they might be, but they don't work in terms of the engagement. It's a huge difference when you deliver that same information through something that's physically there in front of you. Question right here.
What I asked, so basically, this question is going to be going back and what we were saying earlier about the diet.
Okay.
You know how you're saying that the average diet lasts like 3 to 6 weeks? That's assuming your parents are not too serious about it.
Well, that also works for your parents.
Am I correct?
So the challenge is not about being serious about a diet. So the question was, from in front here, you know, the average diet only lasts 3.5 weeks if your parents aren't too serious about it. But the reality is, even if we're serious about it, it's just really hard to stick with something for a long period of time. Question back here.
So have you looked at robots that can actually interpret what you're eating and then scold you? Like, let's say like you get like pizza. I know like you're working on like refrigerator technology where like it'll tell you when milk.
Yep. So the question was, have we looked at robots that can look at what you're eating and scold you? So let me take that in 2 parts. Part A, look at what you're eating. That's actually a really difficult problem to solve for a number of different reasons, not the least of how many meals in the last 7 days did you eat in your kitchen or dining room at home? Right, so probably not a large number for many of us. And the other issue with that question is around scolding. Okay, so one thing that we found is actually a robot that's very supportive and helpful is much more useful. So let me jump forward. This is the first version of what has evolved into the product that you see in front of you. So this is Autom, the version that I built in MIT starting around 2005. And since obviously there are a few of us MIT geeks in the room, I'm going to step through the construction process, or a little bit of it, in just a minute. I'll get your question in 1 second. But this robot was built in small quantity. We built about 17 of these, and we did a randomized controlled medical trial. So we enrolled 45 patients. 15 of them received one of these robots delivered to their home. Another 15 received a computer, same touchscreen as is on the front, exact same software. So in terms of its ability to adapt to the person, learn about them, automate the record keeping, right? Help keep track of eating and exercise each day. It was exactly the same. And the third group of people received what is still today's standard of care in most weight loss clinics, the pencil and paper log, right? Write down each day how much I'm eating and exercising. I'll come back to the results in a second. We've got a couple of questions. Yes?
Are those ridges on the head supposed to be a hairstyle?
Yeah, so the question is about the ridges on the head. Yes, those are the hair. Give me a break. I designed most of this myself. Okay, I'm not a designer or an artist. Go easy on me. Other questions? Yes, right in front.
So this one is basically a version of that, but it's plugged in with wires.
So this one gets plugged in also. This one you can see. So the size of that one is about this tall, which is about this big. So this was built in, let's see, so someone who helped me is actually in the back of the room here. When were we building these? Around 2005, 2006?
Yeah.
You were helping with the software side of it then?
The mechanical?
Yeah, that's right. So it took a lot of work to build these. And we were using off-the-shelf technology. So, you know, big computer motherboards. Those are before your time. Don't worry about it. You couldn't buy anything like this at that time. Something that was this powerful was about this big. So just what we had to work with in building this took a lot to fit it in there. So not quite as elegantly designed as what we're working on getting towards. Question towards the back.
Have you built any like self-contained robots?
What do you mean by self-contained? The question is...
No wires or processing, sort of like an iPhone where you can just keep it in that small...
So this one is pretty much self-contained, just needs power. And we can put a battery in it if we want to. Other questions? All right. So just for fun, we've got time. I'll talk a few minutes about the construction process. This was sort of in the earlier days of 3D printing. You couldn't print something very big. So you can see these are to make the molds, to make the head. Those lines there, you see where I put it back together after having 3D printed these in multiple pieces. This was the old Z-Corp machine. I don't know if any of you guys have used one of those. Finicky old 3D printer. You've used it a lot. So printing these, I ended up living in the lab for, I think, about 5 or 6 days, 24/7. Had to monitor the printer because if it ever stopped, you know, as it was printing up layer by layer. and it stopped for more than, I think we had about 15 minutes to go fix it and get it going again. If it stopped for longer than that, we had to throw that whole piece out and start over. And printing one of those quadrants, I think, was around anywhere from 7 to 14 hours, probably, depending on the size of it. So fortunately, we've come a long ways today. We took those, put them together, poured some silicone into them, right? Pulled that out, and then we had some 2-part molds, mixed up some plastic, poured it in there, and then out came one of those head shells that you just saw. Ilya helped out on quite a bit of this stuff right here. So this is a series of the robots with their shells off. So a bunch of our naked Autom robots. Let's see, this was taken, I think this one was actually in the New York Times Sunday magazine, was where this picture came from. So as you heard in the introduction that Ivy gave, one of the things that helped to launch the commercialization of this was starting around mid-2007, we got a lot of attention from the outside world around this technology. So you can kind of see in here, let's see, do I have the laser pointer? Yeah. So you've got a full-size computer motherboard right there, a little touchscreen that I managed to source out of one factory in China that I could find that was making these. Again, this was way before these things. Can you even imagine not having a mobile phone like this? Yeah, tough. And then basically the shell, the kind of structure on the inside, the shell went on the outside, and almost everything from the neck up we designed and built in the shops at the Media Lab. So these were really hand-built. It took us about a year to build all the hardware and software. And I think I rarely left the lab for more than 8 or 10 hours of time during much of that year. So these, of course, came along to, we've started putting the face shells on them. There was a back to it as well. You can see the software start to run there. You probably remember that great calibration interface that we all spent very many hours on getting those eyes lined up just right. And of course, that resulted in what became this robot. So we did build a bunch of these. We did successfully deploy these to homes around the greater Boston area. So I gave you kind of the big picture outline of this study. We enrolled 45 people. When people were enrolling and recruited for this, all they knew it was a weight loss study. Most of these patients were recruited out of Boston Medical Center, some also at other gyms and restaurants around the greater Boston area. Pretty much no one was recruited out of MIT. So we did not want to do a typical psychological study where we do it all on undergraduates of the population that you're studying, right? Question over here and then here.
To me, the camera hole, I guess, by the forehead is a little bit jarring. Is there any reason to put it there, not where, maybe where the mouth would be?
So the question was why the camera in the forehead? A number of reasons around kind of design and placement, just kind of where we could get it. I think that putting it in the camera and having the robot sit there like this would also be a bit awkward. We did some tests of kind of how it might look, and most people actually didn't pay much attention when it was put here. So definitely not an ideal location. Given the camera technology of the time, it was about all we could easily do. This one has a camera embedded inside one eye, so you can't even see that now. Question over here.
Did the enrollees pay for this additional service? I'm just wondering if having to pay something versus not having to pay for it, has an impact on how likely you are to stick to the program.
So the question was about, did people pay for this? In other words, does their payment make them more likely to stick to it? No one paid for any of this. Okay, so this is a completely free trial. At Boston Medical, it was advertised along with many of the other studies they were doing. So in terms of the setup of the study, it was identical to many other studies in the way that they were carried out. So people were not making any commitment by paying for this. Other questions? Question over here.
2 questions.
Yes.
Number one is that you were giving out these robots to people. So are you trying to make these small, or are you trying to make them as lifelike as you can?
Okay, so the question was, are we trying to make these small or are we trying to make these lifelike? The answer was neither one. We were just trying to make them work. All right, so again, we built all of this by hand. It was just enough to get it functioning so it would last for the study. Your second question?
Yeah, so I understand that some people like personal robots. Are people going to use AIs for that?
So yeah, the question is, are we going to replace personal robots with AI? Maybe let's talk about that one in a few minutes when we talk a little bit about the future. I think that's an open question, and I think there's not necessarily one way or the other. Okay, so, one more question.
So you've probably heard of Anki.
Yep.
Featured at the Worldwide Developer Conference by Apple, doing extremely well.
Right.
And their whole vision is these toy cars, but they want to become like the robotics company.
Right. Yes, the question is around the Anki toy cars. Let's also come back to that one in a few minutes. So remind me if I don't pick it up when we talk a little bit about the future in a couple of minutes. So let me just give you the conclusion of this study. So we had designed this study to be 6 weeks long. Okay, and the reason for that is, as I had mentioned earlier, the average diet is 3.5 weeks with very little standard deviation. Now, again, when people were enrolled, they had no idea that this was about any technology, let alone about a robot. This was just a weight loss study to help them keep track of eating and exercise. So the way it actually worked is when someone qualified for the study, so there were some background questionnaires to make sure people were in good shape, should be losing weight, we wanted a reasonably healthy population, right? So we weren't worried about extreme risk in terms of the people participating in this. Once someone qualified, I would give them a call, and we would schedule an initial visit. So there was one visit where I would go into their home. I would give them a series of intake questionnaires about the study, and then I would say, okay, I'm going to give you something to help you keep track of your eating and exercise, okay? And then I would give them either a stack of paper, say, okay, I'm bringing in a computer, or I'm bringing in this big robot, okay? So a bit of a surprise to 15 or 30 of the people, depending on how you look at it. Okay, and then there was an intake dialogue that I followed so that everyone got pretty much the same instructions regardless of whether they got a computer, a robot, or paper. Then there was no human intervention during the study. Okay, so for 6 weeks, we did not interact with them so that we did not influence the study. People were left on their own to use the paper, the robot, or the computer. And the instructions that they were given were to try to use what they were given to keep track of their eating, their exercise, and their weight at least once a day. Very simple. And the reason for that is that's the way that most clinical weight loss programs work now. And the other reason for that is if we know that, if I'm trying to lose weight and I can do those 3 things, keep track of my eating, my exercise, and my weight, I am much, much, much more likely to not only lose weight, but to keep it off over time. So there's a lot of medical clinical research behind that. So I started calling people just a few days before the end of the 6 weeks to schedule a follow-up visit, come pick up whatever I had given them, and give them a bunch of questionnaires and interview them about their experience over the month and a half that they were participating in this study. And before I get to the results, I'll just tell you I could tell a difference when I started making those calls. And that was that people with the paper or the computer pulled out their calendars or pulled it up on their computer, and we would schedule a visit. Given people schedules, the average was about 2 weeks out. People with the robots, however, as soon as I called them, started trying to negotiate with me. Can I keep it just 2 more weeks? Oh, no, she's become like a family member. How about another month? No, it's really working for me. You can't take her back. So once I finally did collect everything, and that actually took a couple more months after the end of the study to get everything back, what we saw is that people with the paper log used it on average for about 3.5 weeks. So it fit in very well with what we knew and what we expected. So that was, of course, our control condition in this study. People who use the computer, right? Again, the exact same technology in terms of the software, the ability to learn about them, adapt to them, keep track of what they were doing. It made a little bit of a difference, a weekly significant result versus the paper log. They used it on average about 4.5 weeks. Okay, and so for those 2 groups, the way the paper worked, it was 1 page per week. All right, you could fill to the bottom of the page, you flip to the next page next week. We gave them 8 weeks, 8 pieces of paper in case they wanted to keep going. We did have, I think, 1 person who made it to 6 weeks. There was, page 7, page 8 were not touched. Again, most of them on average about 3.5 weeks. People who used the computer, we had a database, all the logs of everything that happened. We did have a couple of people make it to the end of 6 weeks. They never turned it on again after that, right? Study's done, I don't have to do this anymore. People with the robot, the average time someone used one of the robots in the 6-week study, the average was 8 weeks. And they kept using it up until the day they finally let me come in and take it back from them. For many of them, before I could leave, they had to turn it on one more time. And go through one more conversation with the robot. A lot of people, I had to take their cameras and take a picture of them with the robot before I could take it away. They really bonded with it. Everyone who had a robot named it. Many of the people dressed them up. When I went back in there, it wasn't this plain white robot. They were wearing hats or scarves. One of them had on a red feather boa. We had a question earlier about gender differences. Here's where we start to see gender differences, okay? I did a bunch of questionnaires, so you've heard a bit about the psychological work I've done. Of course, repeated a lot of that in this study. And in those questionnaires, we really did not see much in terms of gender differences. What we did see is when I talked to people. So one thing I had learned working with Sherry Turkle over several years is a lot about interviewing techniques. So Sherry, by training, is a Freudian psychoanalyst. So she's great at drawing information out of people. I spent a number of years working with her. And one thing I saw was that when I walked in, the women's robots were dressed up. They didn't mind you seeing that. When I started talking about the robot, they referred to him by name. Sally is a great coach for me. She's really helped me out. The men were talking about the robot that was sitting over there. And I had one guy in particular, and I started giving him the questionnaires. And the way this follow-up visit worked is I asked people to do the questionnaires before we really had much conversation so I wouldn't bias their opinion. Right? So I would sit quietly, pretending to work or take notes or whatever, just to kind of leave them alone to do their questionnaires. And I had one man who was a faculty member at another institution near MIT that you may know. And as soon as he starts filling out the questionnaires, he starts complaining. Like, you did a terrible job in designing these. You're talking about this like a person. And we were actually very careful not to in the questionnaires, but he felt like we were. And he on and on, complaining. And please, will you fill these out? And I'll be happy to talk about all this with you in a few minutes. He goes through and finishes them. And so we start talking. And one thing I noticed, we're sitting in his living room. He's got L-shaped 2 sofas right there, and one of them has a little table behind it. And when I brought in the robot, he had me set it up right there. And as you can see, these robots were not tiny. They were not light. They were a little bit fragile. For the most part, people didn't move them. They left them there. But all this time talking to him, that robot was not sitting there. And so finally, I asked him, where's the robot? He said, well, I took it to my office downstairs so I could have private conversations. And I said, oh, really? Because he had a wife and a child that lived at home with him. And obviously, he was not going to tell me about Sally or whatever the robot's name was. So the more circumspect way of asking about this is, when you think about this or refer to this robot, how do you refer to it? And he gets kind of this sheepish look on his face and says, her name's Ingrid. So once I got the information out of everyone, I found out that everyone, man or woman, had named their robot. The dressing up was kind of across the board as well, although more women tended to do that. But in terms of their use of it, we didn't see any gender differences. Question in the back.
So could you talk a little bit about the content of the weight loss assistance or advice that the robot gives? And
sure.
Whether that content, so like the conversations, obviously the paper devices couldn't
right.
have a conversation with people. So what was the actual interaction of the content of it? How is it different than what you get with paper?
Certainly, great question. So the question is about what's the content of the conversation, and the obvious factor that the paper couldn't have the same conversation as either of the robot or the computer. Right, so paper was kind of our ground control case. And in terms of conversation ability, we're comparing the robot to the computer. We kept the conversation and the interaction on this fairly simple. Okay, so everything happened through a touchscreen. We used, so this is Microsoft Windows based. I feel standing here, I should point that out, right? And we're using, I think it was the Microsoft Mary voice. If any of you know speech technology, you might remember that from several decades ago now. But one of the easiest available things at this time. So the voice technology was probably not up to today's standards. Some buttons on the screen here, relatively simple interface. The conversation, so at a high level, it's similar to what we're doing today, although most of the details have changed and all the software has changed. The conversation basically goes through a structure where she gives a greeting, makes some small talk, asks for some information, right? How much are you eating? How much have you exercised? What's your weight? Gives a little bit of feedback and advice based on those things. Makes a little bit more small talk, says goodbye. So I have to say that the interface here for entering calories was a bit cumbersome. You know, today I'd be very unhappy with that interface. It worked at the time. We also gave people a little booklet of common foods and their calorie content. And so people entered the number of calories for breakfast, lunch, dinner, snacks. They entered the amount of the number of steps that they'd exercised that day. So we also gave everyone a little inexpensive pedometer that they could carry with them. And we asked them to weigh themselves and enter their weight if they had a scale at home. So that was kind of the structure of the conversation, and it happened the same way on the robot or the computer. As far as the feedback and advice, we just had a little bit of information that came out of the DASH diet from the National Institutes of Health. So what we had done on this particular version of it was relatively simple in terms of that. Question over here.
If you think how much the voice has improved, I heard the new Windows phone is supposed to be having the new, isn't it like the new thing on the Windows phone?
Yes, the question is about voices. They've definitely improved a lot since then. You know, we were using old technology when we built this about 8 years ago, and since then things have gotten much, much better. Question in the far corner.
Well, you talked about the length of time that the various people stayed on the study. What about the result in terms of weight loss?
Great question. Yeah, so the question is about weight loss, right? So we talked about the length of time. So the reason we were looking at length of time was two reasons. One is to study long-term weight loss. You look at it for 3 years. I wanted to finish my Ph.D. at some point. So there's a logistical reason. The other is that an accepted standard for looking at weight loss in the shorter term is looking at duration of engagement of a patient with a diet program, as it's known to be well correlated with long-term outcomes. So this was a way for us to start looking at longer-term outcomes in a shorter period of time. What we did see is that, as is typical with diets, people, while they were on their diet, lost about 1 pound per week, as expected. So of course, that weight loss varies across these groups during the different durations. What we can anticipate for later outcome is that if you're on a diet for longer, as I mentioned earlier, you're more likely not only to lose weight, but to be able to keep it off over time. So what's really happening, what's theorized that's happening is after about a month, those changes that we make that are part of this diet that we're doing actually become longer-term behavior changes. So we were really trying to get over that 3 to 4 week threshold to get people engaged for the longer term. Did I see another question over here? Yes?
Does your current device sync with all the various activity trackers that we're seeing?
Yes, the question was, does the current device, so jumping ahead a little bit, I'll talk for a few minutes about this. I know we don't have a lot of time left tonight. So we've gone a long ways in terms of the design of the robot, and even further in terms of the software. So the system is much more intelligent and adaptable now in terms of what it can do. One of the things that we started to do is to integrate with any device that has a cloud API. So I have my Fitbit in my pocket. I can interact with that, my Withing scale. Right now, about every week, there's a new device coming on the market that we can interact with. Was there another question in the middle here? Yes?
Were any of the people who participated in the study allowed to purchase one and continue on?
Hopefully in the future when we get to bring these to market. So we're in the process of doing that right now. So the question was, do any people in the study get to purchase one of these and keep working with it? And part of the challenges there have to do with, once I was no longer officially affiliated with MIT, I no longer have any access to that data. So that has to do with privacy laws around running any sort of human subjects studies. So I don't have any way of directly going back and contacting those people. Question?
Are those two the same robot?
Yes, they are. That's a close-up of her face. That one is actually this one. Yes?
Those very photoshopped effects.
There actually is not. It's all lighting. Yep, there's no Photoshop. So this was a photographer took this picture. Yes?
Are you addressing any specialized diets, like for diabetics?
We are working on things around specialized diets, as well as other applications. So let me talk about kind of where I've gone with this since leaving MIT. So the core of what we've really been building is this relationship model. So obviously the robot is an important part of this and a lot of what we're talking about tonight. What I think is the interesting technology that we've built is turning psychological theories into artificial intelligence algorithms in a way that are effective at helping people. So the core of the software in this is how we think about it right here. So it's all about this relationship model. So looking at how we as people create, build up, and maintain relationships over time. What are the factors that go into that? And then how does that influence our behavior with other people? So we're taking that and turning that into the brains behind this robot. And the output of that is simply a piece of conversation. And the way that we look at this is that's kind of this middle piece here that we've built around how do you create that relationship, how do you keep that up over time, and then how do you generate a conversation with someone. And then that allows us to build other applications on top of that. So whether that's this example of weight loss that we did at MIT and Boston Medical, whether it's helping me manage my diabetes, deal with some other chronic disease, take a medication, there are a lot of different applications for this technology way beyond the weight loss example that I gave here. So just kind of a quick sense of how this works. Right? What it's doing is it's adapting to someone over time, right? Really adapting the conversation. So one of the goals behind the product is that no two conversations are alike, regardless of what the topic is going to be. And in terms of looking across the clinical landscape in terms of weight loss, so this is Dr. Apovian, who I worked with. She's been doing weight loss studies for several decades, and this was a quote directly from her. This is one of the most effective things that they had seen. So we see that engaging people in this way really does work well, right? So the fact that this thing is sitting there on your kitchen countertop definitely makes a big difference versus an app that, oh yeah, it's on page 3, I need to go open it up again and use that. So having that physical presence for a lot of different reasons does have a big effect on people. So I just want to wrap this up with a few minutes of thinking about where this is going, right? So we've talked a lot about the history of robots and where we started, right? So big industrial robots to help us do manufacturing that probably just get programmed and do something different a few times over the duration that they're used, but there's not a lot of variability. Where something like this is extremely different in terms of how it's used, right? No two conversations with this are alike. It's always adapting to each individual, right? We had a good question here earlier about if you teach one robot something, can it do the same to all the other robots? And in a sense, we're teaching this something about relationships and interaction and psychology, and we can do that across many of them, and they will adapt to each of us because each of us are actually unique individuals. And the way we want to work with this is a little bit different. So if we look at this in terms of commercial technology, we may not all use our Roombas, but they've made great strides in terms of building a product that a lot of people wanted. Right? There are millions of these in homes around the US and around the world. And this was a great starting point because it's a single-purpose technology. It does one thing, and it does it well enough that many people do keep using it. So I see the robotics industry starting in two places. So one is single-purpose robots like this. There's a number of these. And the other is entertainment robots. Anybody have one of these? Yeah, the Pleo, right? So an entertainment robot, the barrier to entry is a little bit lower, right? It has to amuse me for a little while. That's all it has to do. It doesn't have to solve an immense, complex problem. So we're seeing a lot more growth around this type of product. And people are also figuring out the business side of it. So this company in its first incarnation had a lot of challenges on the business side and the cost structure building a product like this. But now you see companies like this. So this is the Romo company called Romotive. They're now here in the San Francisco Bay Area. So relatively simple entertainment robots. And we're kind of building up in capabilities from there. You know, this is an example from Korea, educational robot. I've been in classrooms in Japan where similar robots are starting to be used. Definitely not at scale. These are still research. But that's starting to change very quickly. So I think we're going from this idea of, you know, these heavy commercial robots that those of us in this room understand how to interact with or to program or to make do something, to things that, you know, we can put out in the world and will be really simple for anyone to use, whether they have a degree in technology or have never owned a computer, like one of the people that I had actually in the study of the first version of Autom. So I think that's where this technology is going. As the technology becomes more complex, the fact that we're adding in this social interaction to it makes it so much easier to use, makes it so much more accessible to all of us, opens up so many more applications that we can do with it. So I'm very excited tonight that we had a very young audience overall, because you guys who are playing with robots, you're going to be the ones building the next stuff like this. So keep at it. All right, so that is the end of what I have to say. I can stick around for a while and answer questions. I know we had a hand up over here. Let me take that one.
I just want to make a comment. So when I was at MIT, so Colin Angle, who's the founder of iRobot, is it iRobot? Sorry, not iRobot.
Yeah, Colin's one of the founders of iRobot. Here's
people make the Roomba. So he talked about, I don't know if you guys know, for the first 5-6 years, the Roomba went nowhere. And the main reason for that, because it had no human aspect, and they changed their entire marketing strategy. I know we were talking about even DaVinci earlier, and how successful their sales have been. But people started treating their Roomba as a pet, and sales went through the roof. But he was very, very close to having to shut down the company completely. So.
Yeah, iRobot went through many iterations of product and design of that product before they finally found something that was successful. Yes?
I don't know if you've decided yet, but what about price point for something like that?
So the question was about price point, and we're trying to make this robot as accessible as possible. We are negotiating some deals to try to get this into production very soon. When we started this company, I would have to say we were definitely ahead of our time 6 years ago. So we're trying to launch it somewhere around $200 US. I think that could come down in the future, but I think that's somewhere in that area is where we'll start. Question?
So can you do a quick demo for us?
Can I do a quick demo? Absolutely. So this one right here is a fully working prototype. It's a few years old. So she's traveled, I think, somewhere around 400,000 miles with me in the air. So she's getting a little worn. And it's older electronics on here, so it takes a minute to start up. So I will take another question or two and then come back and give a demo. Ivy.
So do you see that this is going to be directly selling to consumer, or do you see that you're selling to like healthcare insurance company, hospital, etc.?
Yeah, good question. So the question was around what's the sales channel. Is this going direct to consumer or through hospitals, insurers? And I think it really depends on the application. So there's a couple of factors here that it depends on. One is the application. For a weight loss coach, I can sell that directly to consumers, both because the way we think about weight loss, particularly in the Western world, is it's, if I want to lose weight, it's something I manage on my own. So I go out and buy something. If we look at type 2 diabetes as a contrast, 90% of type 2 diabetes is correlated with excess weight. So managing a lot of diabetes is about eating healthier, exercising more, and losing weight, right? So same thing, but we think about that as a medical condition. So if I want something maybe that looks like this to help manage my diabetes, I'm going to get it if it's prescribed by my doctor and paid for by my insurer. So that said, we're looking at both channels right now. And as we go into more of the medically focused applications, then I think we look to more of the traditional healthcare channels. But at the same time, the whole market around healthcare technology is starting to change. So we've seen an evolution over the last couple of years, and I think that's going to pick up in the next few years. So the way we think about healthcare technology and where we buy it 3 years from now might be at Walgreens or Walmart instead of from our doctor. And I think that's harder to predict where we might be. Yes?
Since we're in Silicon Valley, can you give us a sense of what the silicon content is in this device, what the microprocessor is, how much memory it needs, and all the rest of that?
So the question is, since we're in Silicon Valley, can I talk about the silicon? What's the processor, the memory requirements, et cetera? And the answer is no. Not that I don't know what's in it, but I don't think that's what's important about this device, right? The reality is, with an older generation iPhone, for example, a first generation iPhone, that like equivalent to that level of processing power and memory and the camera on there and the microphone, the speaker, everything about it is more than enough to do what we need to do on here, right? As processing power continues to increase greatly, I'm more focused right now in using something that might be a generation old, which means what, 3 or 6 months, and bringing the cost down on this, rather than saying, ooh, you need absolutely the best screen resolution and a bigger screen on it. That's not what's important here. It's about the algorithms, how we use it, how we interact with someone, and really improving the healthcare outcomes rather than making sure we have the most gigahertz and megabytes of RAM on this product. Okay, we've got a bunch of questions. I will come right back to them. Let me give you a short 20 or 30-second demo. So I'm not going to go through a whole conversation here. So with this version of Autom, so for those of you who can't see in the back, she's got 5 names on the front, so I can choose who I am. There is a camera in her eye that on this one is doing face detection, so she can tell where my face is. In typical interaction, I'd be standing in front of her. So she'll actually make eye contact with me and follow me throughout the conversation. And we're working on integrating face recognition also. So instead of touching my name on the front, she would know who I am. But I'll touch a name to start her off.
Hello. I hope that we can work together to help you to meet your weight loss goals.
So in general, the way she works is shows what she's saying on the screen and speaks aloud, right? A couple modalities to make it very easy to interact with. At this point, I use the touchscreen to respond. In the near future, I can also say something that's on the screen or similar. So I'll press, good to see you, Autom.
I bet that your day is more interesting than mine. As a robot, I just sit around waiting to help you out. Maybe in the future, I'll be able to do even more for you.
Okay, Autom.
Is there something specific you'd like to discuss before you tell me about your day?
All right, so I'm going to leave her up here if you want to try her out. But in general, what's going to happen is the structure of the conversation stays the same. There are a couple different conversations that she can have. But in general, she'll make some small talk, ask about what I've been doing, or if I've already synced my Fitbit, for example, she'll say, yeah, great, Cory, you've already walked 7,000 steps today. Maybe one more walk before dinner tonight. And then give some feedback, advice, make a little more small talk, and say goodbye. So that structure always changes, but all the details of the conversation are constantly evolving. Question in the back.
What's your strategy on data integration with back-end databases that have, for example, caloric information, nutritional information, et cetera, so that people can make more informed choices based on the information the robot gives them?
So the question was around what's our strategy in integrating back-end databases around caloric and eating information. I'm going to give the short answer here because that gets into a very detailed answer that I'd be happy to have with you offline. Short answer is we're working on that. We have some integration done. We've done some complete integration in the past with some older databases. I was not happy with the user experience on how we use those, so I'm completely rethinking how that happens. There's a lot of exciting stuff happening in that area that we're working on some integrations, particularly around mobile devices. So we don't see this as a standalone device. The way it interacts with my pedometer in my pocket, a mobile app that may come from our company or another company, web-based interactions, there's a lot of opportunities there. So I think that's definitely important, and let's talk about it afterwards. Question here.
I was just wondering why you changed the eye color from brown to blue.
Question was why we changed the eye color from brown to blue. So the quick answer of that is we did the product design around this and chose the blue for this this whole prototype here. Everything that you see on here in blue is designed to be easily changed. So the idea would be, as we scale up manufacturing, you can order it in the color that you want. Right in front.
So this robot, as we know, it's meant for helping you in diets, right?
Right.
Do you ever plan on making it so you could have goals about different things besides diets, or a system where you could set goals, where you could set a goal, and then you could set a unit, and then you could set a title?
Yeah. So the question is about having a system where you could set a goal and units and titles. So besides diets. So we really focus on the healthcare applications and on making this easy to use. So rather than have someone have to come in and program this, imagine someone who is not necessarily wanting to program a robot like you do who wants to use this, right? We want to make it really easy. You know, the goal of this is that there's no product manual. There's nothing to read. You plug it in, turn it on, and everything else is through conversation. So I think this technology could be used in a lot of other places, but we're going to be really focused on using it in healthcare. Right in front.
Psychologically, what was the most challenging part of designing this robot so that people would use it?
So the question was around psychologically, what's the most challenging part of designing this? There are a lot of complex problems. I would say if we wanted to pick out one piece of it that was most challenging or took the most design time, actually I'll give you two. One was the shape of the head. We spent more iterations on the shape of the head than anything else. And I learned a whole lot about how slight changes in curves can give you a very different emotional perception, particularly if you look at what's going on around here. So for those of you who can't see the robot, like the curves around the side of the face make a huge difference if you vary those just a little bit. And the other is the eyes. So if you come up and look at the eyes, they're, even when she's not moving around, they're pretty engaging. The actual way we build them, really dead simple. The process that went into designing it took a lot of work. So we had a question on the far side here. Yep, you.
For networking, is this a network device, or is that
So question is this a network device? Yes. This current version of it uses Wi-Fi. Next generation, I anticipate going directly over the cellular network. So that's how we connect in with other devices and share the data. So again, we do not see this as a standalone product. It's the way this ties in with a lot of other healthcare applications and technologies that make it really valuable. Yes?
This would be so helpful getting little kids to brush their teeth and keep track of
Yes. So just a product suggestion here that this would be helpful for kids brushing their teeth, and I concur. Let's work on it. In the back.
Have you considered any aspects of gamification?
Like what? So the question's about gamification.
Right. So that's an area which conceivably, if this is a goal-directed activity, but you still might be able to engage them at a different level if there's some other reward structure that is more like a game or a video game, but still integrated with the goal that you have.
Yeah. So I think gamification is in some senses, overused word. Right? So it's hard to narrow down. We have looked at a lot of the psychological theories that are behind gamification and how you increase engagement. And I think that we definitely do some of that here. There's a lot more that could be done. I think that's a big opportunity with this. In the middle.
Yeah, how much do you think about Autumn's voice? I mean, I know that you use the Mary voice, and I noticed that when she talks, it doesn't always go up at the end of the sentence when it's a question, and it doesn't really sound like a person talking.
Right. Yeah, so the questions about the naturalness of voice. Building voices is really difficult, right? And doing a good voice is incredibly difficult. We are licensing a voice from Liquindo, one of the major creators of voices. They were actually bought by the same company that provides Siri's voice, for example. So there really are not that many companies out there. We look at things like that as we'll continue to integrate them into a product like this as the technology improves. It would take a whole lot of work on our part to try to do better than that. The other thing is we don't necessarily want to be completely human-like, right? So this kind of goes to the concept of the uncanny valley that some of you may have heard of or be familiar with. And that's if we get parts of this that are human-like, and this was why we made an explicit decision to not use a recorded human voice in this, you start to get a disconnect between one of your senses and another, right? So if this sounds just like a person and does a perfect voice, but it looks like this, there's something a little bit jarring there. And it's kind of like that example I gave of Mel earlier, where you're not necessarily going to consciously know what that is, but it does greatly impact your perception of the overall experience. Yes? Okay, last question. Make it a good one, no pressure.
You mentioned you're working on making it so that I can actually talk back to the robot. Right now we have to select our answer, right? How much of an impact do you think that will have on the adoption rate and just how people really connect in humanizing the whole robot?
So the question was, I talked about how we're working on integrating speech recognition so I can talk to her and how important of a difference that is. And from the work I've done so far, both academically and commercially, I think it's more of a marketing difference than an actual difference in relationship. People get really drawn into interacting with the robot as it is. I think it will add a little bit, but not a tremendous amount. So with that, I want to thank everyone for coming. We had lots of great questions. I really enjoyed this.